Alright, this video is going to go over the Unit 2 review FRQ questions. You've probably seen in the last one that these are not necessarily all Unit 2 concepts, but they contain several Unit 2 concepts. So, for this first question, we've got a piecewise function, and that piecewise function has a square root and a trig function in it. And part A asks us to find the average rate of change of f on the interval from -3 to 4. And so average rate of change is something that they ask about fairly often, and it's something we want to be prepared for. And if we're wanting to find the average rate of change of f on the interval from -3 to 4, what we need is the slope through the endpoints. That's what we're looking for. And slope formula is just y1 minus y2 over x2, x1 minus x2. So in this case, you would do f of 4 minus f of -3 all over 4 minus -3. Okay, and in order to be able to do that, you have to be able to find f of 4 and f of 3. So let me flip over here my work just so I can check as we go. Hold on just a second. All right. So f of 4. 4 falls right here in that second category from 0 to 4. So we would have -4 plus 3 cosine of pi times 4 over 2. And 4 divided by 2 is 2, so that's cosine of 2 pi. And cosine of 2 pi on the unit circle is 1. So you're going to have -4 plus 3 times 1. And so you're just going to get -1 for that. So up here we'll get -1 minus. And then we also have to find f of 3. And so f of 3, I'm sorry, that should be -3, is going to be the square root of 9 minus -3 squared. And that's going to end up being 9 minus 9, which is 0. So we just get 0 for that value. So we get -1 minus 0 over 7. So we get -1 over 7 for our average rate of change for this problem. I'm going to circle that since it's kind of in an odd spot there. So average rate of change is just slope through the endpoints is what you're looking for there. Let's go on to part B. Part B asks you to find the equation of a tangent line to the graph of f of x at x equals 3. So, for this, we first need to find f of 3. And f of 3 is going to use the bottom function there. So we're going to have -3 plus 3 cosine of pi times 3 over 2. And that's cosine of 3 pi over 2. And cosine of 3 pi over 2 is 0. So we're just going to get -3 for our answer here. Good news for you guys this year is you can use a calculator on the AP exam. So if you don't have that unit circle memorized, you don't really need to have the unit circle memorized. Although I would suggest it for if you're going to take other college classes later. But you don't have to have it for this exam. So we get -3 for our f of 3. That tells us that our point for this line of, our point of tangency here, our point for our tangent line is going to be 3, -3. We also need the slope, and to have the slope, we need to take the derivative of f of x. So I'm going to say f prime of x equals, I'm only going to take the derivative of this second one right here, so I guess I should probably over here put 4, 0 less than x less than or equal to 4 when I take that derivative. So the derivative of -x is just going to be -1. And then we're going to take the derivative of 3 cosine pi x over 2. Oh, let me cut this off. Sorry. So the derivative of cosine is negative sine. So we'll have -3 3 sine of pi times x over 2. But whenever we take the derivative of a function like this that has other things on the inside, we have to take the derivative of that inside value. You have to use the chain rule. And so the derivative of pi x over 2 is pi over 2. There. So f prime of x is going to equal -1 minus, I can put that 3 and that pi over 2 together, so I'll have 3 pi over 2 sine of pi times x over 2. Alright, and again, this is only for 0 to 4 here. It does not apply to the -3 to 0 range. But we don't need that because we're finding f prime of 3. So we'll have -1 minus 3 pi over 2 sine of pi times 3 over 2. And 3 pi, sine of 3 pi over 2 is going to give us -1, which means right here we're going to get -1 plus 3 pi over 2. And this is our slope of our tangent line. The derivative gives us the slope of the tangent line. So now we have the two things that we need to write this equation of this tangent line. So we're going to have y plus 3 equals, I'm going to put my slope in parentheses, -1 plus 3 pi over 2 times x minus 3. And that will be my equation for my tangent line there. So this part right here is my answer. Okay, let's move on to part C. Part C says to find the average value of f on the interval from -3 to 4. Now, let's look at the difference between A and B. A asks for the average rate of change. So when you are finding average rate of change of f, that is the slope through the endpoints. That's f of b minus f of a over b minus a, like that. But if you're finding average value of f, then that is where we do 1 over b minus a times the integral from a to b of f of x dx. So that is what we have to do here on part C. That's our average value. So we're going from -3 to 4, so we'll do 1 over 4 minus -3. That's just our length of our interval, how far it is from -3 to 4. And then we're going to integrate from -3 to 4 f of x dx. So this is going to give us 1/7, and when we integrate here, we're going to have to split this into two separate pieces. So we're going to have to integrate from -3 to 0, and our function from -3 to 0 is the square root of 9 minus x squared. I'll put a dx right here. Plus, we also have to integrate from 0 to 4 of -x plus 3 cosine of pi x over 2 dx. Here. And I'll parentheses there, although I ran out of room. Okay, now, this problem originally was written where it was calculator inactive, and you were supposed to solve all of that with your without your calculator. However, this year's test is going to be calculator active. I don't think you're going to see this part of this problem on the exam because the calculator gives you a major advantage here. So I don't think you're actually going to see this part of the on the exam, but if you do, you can use your calculator. So I'm just going to write up, I don't have the calculator where I can show you what I'm doing, but I'm going to write what I would type in. You would go to F3 and number 2 for integrate, and so you get that integrate and that symbol, and you would type in square root of 9 minus x squared, comma x, comma -3, comma 0. And whenever you do that, you will get 9 pi over 4. And for the second one, you'll do negative x plus 3 cosine of pi x over 2, comma x, comma 0, comma 4. And that will give you -8. And so use your calculator for that. You can solve those using the calculator. Now, I will tell you that what I just did right there is a major no-no on the AP exam. Don't write this calculator notation down on your AP exam. They do not accept that. Make sure you have written the actual integral notation right here. They do not accept calculator notation. I'm just writing that up because I can't show you how to type it into the calculator because I don't have that calculator on this computer like I do at school. So what we end up with is 1/7 times 9 pi over 4 minus 8 right here. Leave it like that. Don't touch it. That is your average value. If you wanted to get a decimal for it, it is -0.133, but that is really not necessary here. Okay, so that is part C. The last part, part D, says, must there be a value of x at which f attains an absolute maximum on the closed interval -3 to 4, justify your answer. So this problem is really asking you about the extreme, let me type this, extreme value theorem. And the extreme value theorem tells you if a function is continuous on an interval AB, then, actually it has to be a closed interval, AB, then the function must have a maximum and minimum value on that interval. So if the function is continuous, extreme value theorem tells us there's got to be a maximum. It could look a lot of different ways. It could look something like this, where your maximum would fall right here. It also could just be like a straight line like this, so your maximum would be right up here at the top. It could be a horizontal line, and every point would be a maximum, and every point would be a minimum. That probably is not going to happen. But the main thing you have to do here is show this is continuous. And so to show something is continuous, you've got to use limit notation. If you're going to have a problem with continuity, it's going to be at 0 right here, because this function is continuous from -3 to 0, and this function is also continuous from 0 to 4. So right there at x equals 0 is where you're going to have a problem. So what you've got to do is you've got to do the limit as x approaches 0 from the left of f of x, and you have to put this notation or you will not get credit for this part of the problem. And so you can plug in 0 to f of x. From the left, you would be using this top function. So you would have the square root of 9 minus 0 squared, which is going to give you 3. You also have to check the limit as x approaches 0 from the right of f of x. And so you would plug in 0, -0 plus 3 cosine of, that's going to end up being cosine of 0 when you plug that in. Cosine of 0 is 1, so you end up getting 3 for this one as well. There is one other thing that's easy to forget for continuity. You also have to say f of 3 equals 3, which is true, because if I plug in 3 into the appropriate equation, I would plug in 3, I'm sorry, not f of 3. Let me fix that. It's f of 0. Oops, sorry. Reminding me to get up and not sit down so much. Alright. Okay, so f of 0 equals 3. And so since f of 0 equals 3, that just means if you plugged in 3, you would use this top equation, you would get 3. And so since all of these are true, we can say therefore f is continuous on negative 3, 4. And let me just type again, because that'll be easier to read. Therefore, by the extreme value theorem, f must have a maximum value on negative 3, 4. Alright, so I'm not sure if you absolutely have to say extreme value theorem there. You could just logically think, since it's continuous somewhere, you have to have that maximum value, but you're safest if you say extreme value theorem for that one. So that is question 1. We are going to go over to question 2. Question 2 is a good question because it has a graph. I feel like there's a good chance you're going to see something like that on the exam, because the exam is going to try to give you something you cannot type into your calculator, and you can't type graphs into your calculator. So number 3A, ask for the average rate of change again. So average rate of change for part A is going to be g of 5 minus g of negative 5 all over 5 minus negative 5. It's the slope through the endpoints. So you're going to have to find g of 5, and they tell us that g of 5 is g of x is the integral from 1 to x of f of t dt. So this will be the integral from 1 to 5 of f of t dt, and so that is the area underneath the curve from 1 to 5. So you are going to just find the area of, you could do the whole thing as a trapezoid here, or you could do a triangle and a rectangle. I think I'll do the trapezoid. Your formula for the area of the trapezoid is 1/2 times the height, which your height here is going to be 4, times base 1 plus base 2. So the bottom base is 4 and the top base is 2. But again, if you want to do a triangle and a rectangle together, that'll work as well too. So you're going to end up with 2 times 6, so you will get 12 for that. So your g of 5 here, that's going to be 12. If we continue on, we got to find g of negative 5, which is going to be the integral from 1 to negative 5 of f of t dt. And I don't like the way that looks right there, because 1 is larger than negative 5. So I'm going to flip that around, and when I flip it, I've got to put a negative out front. So integral from negative 5 to 1 of f of t dt. So whatever I get right here has a negative out in front of it, so I'm going to change its sign. Now notice, from negative 5 to positive 1, everything's beneath the x-axis. So this means you're going to have negative values for those integrals. So from negative 5 to negative 2, you've got a triangle there, so it's going to be negative 1/2 times 3 times 4. You've got a quarter of a circle here. It's also going to be negative because it's below the x-axis, so it's going to be 1/4 pi 2 squared, a quarter of pi r squared there. And the last part's that little teeny triangle right there, and it's just going to be 1/2 times 1 times 2. And technically you could leave it like this, but since we've got to do something else with it, let's simplify it. So you have negative, and then this will be negative 6 minus 1/4 and 2 squared are going to cancel each other out, because you got 1/4 and 4, which is just 1, so you've just got the pi there, and then 1/2 times 1 times 2 is 1. So this is going to be negative 7 minus pi, and if you distribute that negative there, you will get 7 plus pi. So that is your g of -5. So you'll have up here, where we were at, up here you will have parentheses 7 plus pi. Don't forget those parentheses or your answer is wrong. And then 5 minus -5 is 10. I would not simplify anything right there. I'd probably circle it, especially since it's way up there at the top where you can't tell it's the answer. I just leave it like that. Now, if you want to combine the 12 and the 7, you can. Just be really careful if you do, because you're going to get 12 minus 7 minus pi. It's really easy to lose that negative with the pi. So you would have 5 minus pi over 10. You could simplify. I would not for that. So that's part A. Okay. Part B says find the instantaneous rate of change of g with respect to x at x equals 3, or state that it does not exist. This part is actually really quick. Let me go back to black here. This part is really quick because we're wanting instantaneous rate of change, which is the derivative of g. So g of x, it has already told us, is the integral from 1 to x of f of t dt. So if we're taking the derivative of this, g prime of x is going to equal, the derivative undoes the integral here, and we're just going to get f of t here. Technically times I'm sorry, that's not t. That should be x. F of x right there. The x will replace the t right there. So, g prime of 3 is just going to be f of 3. And if we scroll back up here to the graph, f of 3 is right here. The y-coordinate that goes with your x value there is 4. So you get 4 for your instantaneous rate of change. So it'd probably be best to say the instantaneous rate of change of f at x equals 3 is 4 right there. I'm not sure that would be required, but it will not hurt anything for you to write that out. Let's continue on. Part C, it says, on what open intervals, if any, is the graph of g concave up? Justify your answer. So let's think about what we know about concavity. I'm going to make us a chart we've made many, many times right here. So I know if I'm looking at the second derivative, and actually let me just, this is just general, this is not related to the problem. I'm going to use something that's not, let's just use like a y prime and a y double prime right here, because I'm just generalizing right now. I don't want to use the values that are actually in the problem. So if I'm talking about concavity, I'm worried about whether it's concave up or the graph is concave up or concave down. So the second derivative, if it is positive, that tells us that y, or the original function, is concave up. And if the second derivative is negative, that tells us the graph is concave down. Alright, so if we think also about increasing and decreasing, if y is increasing, that means its derivative is positive. If y is decreasing, that means its derivative is negative. Now, that's not necessary for this problem, but if I know I have a positive right here, then the first derivative, that tells me that that would be increasing. And if I know that the second derivative is negative, that tells me that the first derivative is decreasing. Sorry. So if the first derivative is increasing, then the function is concave up. If the first derivative is decreasing, the function is concave down. You do not have to write all that stuff out that I just wrote out. I'm just trying to explain it to you for those of you who might have forgotten that. So if we look at the graph, we are increasing here from -5 up to -2. We also increase from 0 up to 3. So those are our places where our graph is concave up. So what we're going to say for that is that first I would begin with since g prime of x equals f of x, which we stated on the last problem, so I'm not entirely sure we got to say it again, but it doesn't hurt. And f of x is increasing on -5, -2, and 0, 3. G of x is concave up on these intervals. Okay, so that is what you would say for part C there. So we got one more part to look at. For part D, it says find all x values in the interval from -5 to 5 at which G has a critical point. Classify each critical point as the location of a local minimum, a local maximum, or neither. So for part D, we're looking at this graph right here. It will not hurt here to state one more time that g prime of x equals f of x right here, to let them know you know that this graph you're looking at is really the derivative of g of x. And so if we have a critical point, it's where our derivative equals 0. So so we could say g of x has critical points at x equals -2 and x equals 1 because g prime of x equals 0 at these points. Or you could say f of x, either one. It doesn't matter. You have stated that they're equal to each other up here, so you could use either one whenever you're talking about this right here. And then we would say at x equals -2. At x equals -2, we do not have a maximum nor a minimum because our derivative does not change signs. So at x equals -2, there is neither a local max nor min because g prime of x does not change signs. And then at x equals 1, there, and I really shouldn't say there is. I really should say right here, g of x has neither, because we want to be specific about what graph we're talking about here. And we're talking about the graph of g of x. So g of x has a local minimum because g prime of x switches from negative to positive. There. So that would be our answer for part D. So I hope this is helpful to you. If you have questions, we are going to have a meeting tomorrow, so you can ask questions about either the Unit 3 questions, or you can ask questions about these if you have any.